So another very important theorem that we talk about in calculus is called the mean value theorem. And the mean value theorem is very similar to Rolles' theorem. It states that we've got a function f that is continuous on a closed interval from a to b and differentiable on an open interval from a to b. If that's the case, then there's at least one point c in a to b such that f prime of c is equal to f of b minus f of a over b minus a. And many people look at that and think that, well, that's sort of a mysterious kind of little formulation right there. What does that really mean? Well, in effect, what this is stating is that if we were to look at it, I'm going to make a couple colored lines right here. Let's try red. Red's a nice color here. A little bit of a thin line here. Okay, so let's say that we're looking at f prime, f of b minus f of a over b minus a. What does that really mean? Well, we might take a point like this function right here that starts at 0, 3, and a point right here that's at 3, 0, and look at the slope of the line that passes through those 2 points, right? That is the slope f of b minus f of a over b minus a. In other words, it's the slope of a line that passes through 2 points at x equals a and x equals b. What else does this theorem say? Well, let's make another line this time. I'll choose the color blue. It's a nice shade of blue here. And we say, well, all right, then this theorem tells us that there's some point c in between a and b such that, and I'm going to just make this line parallel to the other one, such that we should be able to find a point somewhere in between the interval, between a and b, such that the slope of that line is tangent to the curve at that point C and parallel to the line passing through A and B. And a lot of people look at that one and get a little confused and say, well, what's the point of all of that? Well, it turns out to be this is a very central theorem to many of the things that we do in calculus, so we better get used to it now. So, all right, how could we handle this? Well, let's take a look at this function right here. I've got my function 3 plus 2x minus x squared. And let's say that we do have an interval. We know this is a nice continuous function, being a parabola. It's a continuous polynomial function. And let's look at it on the interval from 0 to 3, which seems like a very nice kind of interval for us, because we know that if we took f of 0, this would be the kind of function that we would get 3. Well, plus 2 times 0 minus 0. So f of 0 is equal to 3. And f of 3 is the value, let's see, 3 plus 2 times 3, that's 6, minus 3 squared, that's 9. Oh, that's 0. Well, just like it looks right here on the graph, this graph passes through the point 0, 3 and the point 3, 0. All right, so we might ask, then what are we saying right here in this quantity? Well, we're saying that there has to be some value c such that if I were to take the derivative of my function y equals 3 plus 2x minus x squared, I should be able to find a place where the slope of the line that's tangent to the curve is exactly equal to f of 3 minus f of 0 divided by 3 minus 0. In this case, that's really saying we want to find a place where the derivative is equal to, let's see, 0 minus 3 over 3 minus 0. Oh, well, that comes out to be negative 1. All right, so what are we trying to do? Well, let's find f prime of x. In this case, we know our derivative of our function y equals 3 plus 2x minus x squared will be 2 minus 2x, and we want to find a place, c, such that 2 minus 2 times c is equal to negative 1. So we should go through and solve for c. We do that by subtracting 2 from both sides and finding negative 2 times c is equal to negative 3 in this case. And if we divide both sides by negative 2, we find c is equal to 3 halves. So right here, if we were to look for the point 3 halves, we would find that at this point, f prime of 3 halves is in fact equal to the value of f of 3 minus f of 0 divided by 3 minus 0 by our mean value theorem. A very useful result.